Alright, in this video I'm going to do a second example of solving a nonlinear system by substitution. So looking at this second example here, I'm given x squared plus y squared equals 10 and y equals negative 3x plus 10. Now as you can see, one of the equations, the second one, is already solved for y. So in this problem I'm just going to take what y is equal to, and I'm going to end up substituting it in for the y in the first equation. This will allow me then to rewrite the first equation, and I can rewrite it as x squared plus, now anytime we substitute in for a variable, so I'm plugging all this stuff in for the y, you'll always want to write out parentheses where you're going to make the substitution. So I'm going to substitute negative 3x plus 10 in for the y, so the negative 3x plus 10 is going to go inside my parentheses. Once I've substituted in, you'll notice that the y was being squared, so the parentheses, everything I've substituted in for y, also needs to be squared, and then that is equal to 10 still. At this point in the problem, it's really now about simplifying and solving for x. Well, anytime we have a parentheses or binomial being squared, we can expand it out and multiply it together. So I can rewrite this as x squared plus negative 3x plus 10 times negative 3x plus 10 equals 10. And now I have two binomials being multiplied. If you recall, anytime we have two binomials being multiplied, we use a method called FOIL to multiply these. So just to kind of recall FOIL for a second, FOIL means that I'm going to take the first term times the first term, the outer terms multiplied together, the inner terms multiplied together, and the last terms multiplied together. So we're going to go ahead and do that to this second line here. Well, we're not doing anything to the x squared out front, so I can just write that down. And then that's going to be plus, and now this is where I want to start FOIL. So negative 3x times negative 3x is a positive 9x squared. Then I want to take negative 3x times 10, which is a negative 30x. And then if I keep following FOIL, it now wants me to do the inner ones. So 10 times negative 3x is a negative 30x. And then last times last is 10 times 10, or 100. And then that's still going to be equal to 10. Once again, I'm just kind of continuing to simplify here. So at this point, I want to combine like terms. So notice that I have an x squared term and a 9x squared term. They're both x squared, so I can add those together and get 10x squared. And then I have negative 30x minus 30x, so that's negative 60x. And then I have a plus 100 on the end. And it's still equal to 10. Anytime I want to solve an equation, more times than not I want to get everything on the one side of the equation. So in this case, I'll subtract 10 from both sides. This will leave me with 10x squared minus 60x plus 90 equals 0. And if you notice, these numbers are relatively big, so I don't want to quite factor yet. What I'd like to do is somehow take out a number that is common with each of these. And if you notice, they're all multiples of 10. So what I'm going to end up doing is dividing by 10. But whatever I do to the left-hand side of the equation, I need to do to the right-hand side of the equation. So I need to divide that by 10 as well. Now if I go ahead and do this, 10x squared divided by 10 is just going to be x squared. Negative 60x divided by 10 is going to be negative 6x. And then 90 divided by 10 is going to be a plus 9. And then that'll equal, well, if I take 0 divided by 10, I just get 0. Okay? So I've sort of simplified the quadratic as much as I can. And now, anytime I have a quadratic in standard form and it's equal to 0, I'm going to end up solving this by factoring. So I need to factor it to find the solutions. And if you recall, factoring means kind of undoing the FOIL that we just did. So for instance, what times what will give me the x squared? Well, that's just x times x. And then I need to think about what two numbers multiply to 9 and add to negative 6. Well, in this case, it's going to be negative 3 and negative 3. And then once I have it factored, I can really break this apart into two equations. So this is going to be x minus 3 equals 0, or x minus 3 equals 0. And if I solve both of those, I'm going to get x equals 3 twice. But remember, with solutions to a system, I'm not quite done yet, because solutions to a system are always points, so I need a y value as well. So in this case, it's going to be the same y value because I'm plugging in the same x value. But in order to find the y value, I just have to plug the x that I found down here into the equation up there. So I'm going to get y equals negative 3. I'm plugging in x equals 3 into the equation, and then I'm just solving for y. Negative 3 times 3 is a negative 9. I add 10 to that, I get 1. So when my x is 3, my y is 1. And you'll notice that I have two solutions, but the solutions are the same. They're both going to be the point 3 comma 1. That will be the solution to the system. Just note that you can always check your work. If you take this point and plug it into both of these equations, you should get a true statement for both of the equations. The point should work in both of them.